Binomial products. Bi, of course, means two. Nomial terms. Oh yeah, fair enough. Things with two terms, and we're going to multiply them. This classic question. I've got things with two terms, I'm multiplying them together. Now, I don't know what the first way you were taught how to do this. There's the FOIL method, which is often used. First, outside, inside, last, things like that. Of course, there is the FACE method. Anyone seen the FACE method? Watch and learn. The FACE method, it sort of essentially is the FOIL method, just a bit more fun, because we draw the line in. Okay, so first, x times x, that's x squared. Outside, x times 1, that's x. Inside, do you see it? Do you see it? 6 times x, and last, and look, you got a face. The outside parentheses are the ears, the inside's the nose. You got a smile and some eyebrows. But there you go. The FACE method. Okay. Now, of course, we don't leave it like that. We collect like terms, and we get x squared plus 7x plus 6. Again, in reality, I'm not expecting you to write x plus 6x. That's the sort of thing, yeah, okay, we'll do that in our head. And you write the 7x straight down. We, of course, love saving time in maths. Maths is funny. It's sometimes called the science of patterns. We look for patterns. And if we can find a pattern, then we can use it each time. Now, we sometimes might spend an incredible amount of time looking for a pattern that'll solve us a couple of seconds. But the point is, once we've got it, it's going to save us a couple of seconds every single time. So we tend to do that in maths. So a perfect square, a plus b squared, we know it will always end up in that pattern, a squared plus 2ab plus b squared. Similar with the minus, the middle term becomes minus 2ab. In general, did you know that? Doesn't matter how many terms you're squaring, it'll always be each term squared plus twice all the possible combinations of two terms multiplied together. That will always be true. Difference of two squares, a squared minus b squared. So I see x plus 2 all squared. I go, hang on, I've got a pattern for that. Yes, you would not write this down. But there's the pattern, x squared plus 2 times x times 2 plus 2 squared. Remember, a plus b squared, that was a squared plus 2ab plus b squared. And we come up with our answer, which of course, that is what we just write down, I would hope. 3x minus 4 squared then, bingo! See, our pattern saved us so much time. Bang, there's the answer. Difference two squares. Oh, well, that's the first one squared minus the second one squared. Binomial times a trinomial. This is where drawing the lines can be real useful to make sure you get every possibility. I've got to multiply a by everything, so let's do it. 2 terms times 3 terms. Answer has 6 terms. So a will be times that, and then that times that. Okay, excellent. Now, right, good on you. And we'll multiply that. Brilliant. We know we're expecting 6 terms, and it's a way of checking to make sure we got every combination. So if you are writing the whole thing out, how many terms times how many terms? This is how many I should end up with. Collect any like terms we have there. There's our answer. I don't know whether you've ever seen this before. The method of detached coefficients. Trinomial times trinomial. Here we go. Here's how it works. We list all the coefficients of the first factor starting with the highest power. So 2, negative 4. Notice I wrote a 0 for 0x, there's no x there, minus 5. Then underneath that, we list all the coefficients of the second factor, starting with the highest power. So we've got 3, 4, negative 2. Notice though, I'm not putting it in columns which you might be thinking of. I always start at the front. So the 2 on the first line is 2x cubed, but the 3 on the second line is 3x squared. And we just keep working our way down. Okay, multiply all of the first row by the first number in the second row, writing the first result under the first number. So everything gets multiplied by 3. Okay, now multiply all of the first row by the second number in the second row, writing the first result under the second number. So I'm going to multiply everything by 4, but I start in the second column. Guess what you do next? Multiply everything by the third number, but we'll start in the third column. Now we just add down those columns and we have our answer. Of course, we've now got to put the algebra back in. So the result, there's your coefficients of all your answers, starting with the highest power of the answer. We know the highest power of the answer must be the highest term times the highest term. X cubed times x squared is x to the power of 5. So it must be x to the power of 5. So there's our answer. 6x to the 5 minus 4x 4 minus 20x cubed minus 7x squared minus 20x plus 10. That is what's called the method of detached coefficients. I'll just try another one here. There's the, I think that's the same as the example we did before, isn't it? Just to show you. I could have gone, pick the biggest one to go first. It's usually the easiest. So 1 minus 3 is 7. Then underneath that 1, 2. Multiply everything by 1. Multiply everything by 2. Add them up. There's my answer. Get used to it. It can be quite quick. Certainly for longer ones. Whee! Remember, detached coefficients. I really don't care about the x, y's and all that. 3, 2, 0, 4, 2. 2, 0, negative 1. See, I'm looking at that. The y's I'm not worrying about. I'm just thinking about this as it's in terms of x. So highest power x to the 4, the other one highest power x squared. Okay, multiply, multiply, multiply. There's my answer. When you now put the algebra back in, you just have to remember, as you go along, take 1 off the power, but then add 1 to the next one. So the 2 powers will always add up to be 6 in this one. So 5 and 1, 4 and 2, 3 and 3, 2 and 4, 1 and 5, and so on. There we go. There's our theory.